All right, so I'm going to take a look at solve a 2 by 2 system using the matrix inverse. And the very first thing that you have to do is write this in matrix form before you can find the inverse. You then have to, of course, know what the equation of the inverse is. So if you're doing a 2 by 2 matrix or doing a 2 by 3 matrix, it's very, well, it's not similar, but the idea of the formula is almost the same. So a 2 by 2 matrix, to find the inverse, it's going to be 1 over the determinant times the adjoint. If you're doing a 3 by 3, it'll be 1 over the determinant times the adjugate. Okay, so there's a different process of finding this matrix for a 2 by 2 and a 2 by 3. So right now I'm going to do a 2 by 2. All right, so first thing I need to do is write a matrix so I can find the determinant. So let's go ahead and write this matrix out. So when you're writing out the matrix, okay, you can look at it as just writing out the coefficients. So you're writing out the coefficient of x, which is 2, the coefficient of y, which is -6, the coefficient of x, which is -1, the coefficient of y, which is 7. So just a matrix with the coefficients. And then, of course, what am I looking for? I'm looking for what came first, which is x, and then what came second, which is y. And when I multiply these two, I'm going to get the answer that they gave me. So when I multiply those two, I'm going to get -2 and -5. Okay, so the very first thing is you first write it into a matrix. After you write it into a matrix, we can go ahead and find the determinant of that matrix, right? So we can find the determinant of this matrix. And how do I find the determinant of a 2 by 2 matrix? Okay, I take this, I take this right here and multiply it together. So what do I get when I do that? I get 2 times 7. I get 2 times 7 minus the multiplication of the other diagonal this way. Okay, that's how you find the determinant for the 2 by 2. So minus -6 times -1. This is how you find the determinant. So the determinant is 2 times 7, which is 14, minus -6 times -1. And again, just put this all in the calculator, is +6. And then 14 minus 6 is going to be 8. So my determinant, my determinant is going to be 8. All right, so remember, I'm trying to find the inverse. So my inverse is going to be 1 over my determinant, which is 8. Oh, I don't even have to do that. All right, times my adjoint. Okay, so to find my adjoint of A, you take your original function, okay, and it has to do with the diagonals. You switch these two numbers, so it's going to be, switch them, so 7 here and 2 here. And then you take the opposite sign of whatever these are. So these are negative, so they're going to become positive. If it was positive, it would become negative. So make these positive, but they stay in the same position, just change the signs. So that's my adjoint. So my adjoint is 7, 6, 1, 2. All right, so now that I found my inverse, I can use that to solve the system of equations. So this is my inverse right here. And I do apologize, I wrote something here by mistake. All right, this is my inverse right here. And I'm going to leave it like this, and you'll see why at the end. I'm just going to leave it just like this. To find my solution, remember, I multiply both sides, okay, by my inverse. So both sides by my inverse. And what that's going to do is it's going to make this an identity matrix. And just for time, I'm not going to go ahead and show you that. Okay, I'm not going to show you that. But feel free to go ahead and do it. You multiply the left and the right by my inverse. I'm going to write it here. I'm going to squeeze it in right here. However, I am going to change, and you're going to see why in a second. If I put the inverse on this side, this will be a 2 by 1, and this will be a 2 by 2, right? These are not the same. So I have to put it on this side. So I'm going to go ahead and do that. So these will cross out, and you can do the math if you want to, leaving just x and y. And then I have the 1/8. And again, in order for me to be able to multiply the matrix, the inner one has to be the same. So I'm going to put this first. So 7, 6, 1, 2. And then I'm going to put the other one second. All right, the order of how you multiply matrices are very important. All right, so now that I have that, this is a 2 by 2, and this is a 2 by 1. So what is that? See that? Right? It works out. So now the answer that it's going to give me is going to be a 2 by 1. So let's go ahead and work it out. So I have, running out of space, I'm going to squeeze this in a little bit. So I have x and then y equals, I'm going to leave this 1/8 outside. And this is the reason why I didn't want to multiply, because I don't want to multiply fractions, to be honest. I'll multiply it all the way at the end. So to multiply it, remember it's 7 times -2, which is -14, plus, but so that we don't lose that, plus 6 times -5, which is -30. So that's my first position. My second position is 1 times -2, which is -2, plus 2 times -5, which is -10. That's my second position. So go ahead and combine those like terms. So this is going to be 1/8. And I'm going to have, this is -44. And this one is -12. Okay, now I'm going to multiply it by the 8. All right, and again, you're doing this in a calculator, so this is going to be -44 divided by 8. All right, and then -12 divided by 8. And of course, we have to simplify, right? So -44 divided by 8 in a calculator is going to be 11/2, -11/2. And this divided by 8, 4 goes into that 12 times, so -3, 4 goes into that 2 times. Okay, so you just have to simplify it. Now, that's my final equation. X is equal to this number here, so x is equal to -11/2, and y is equal to -3/2. All right, so it's a couple of steps. So first you have to find the inverse, right? Multiply both sides of the equation by the inverse because it's going to get rid of this side, just like you would do when you're solving equations. And then once you find that answer, you just match up the variable with the answer. And it's okay that it's a fraction. That's not bad. All right, so I'm going to just put this in to show you that we indeed did it correctly. And remember with matrices, one little mistake, you could actually get it completely wrong. So be really mindful and careful when you're doing this to just do it really like slow. So let's put in the answers that they want. So they want the inverse and they left the fraction there. So I'm going to put that fraction in there. 1/8. In these boxes, I have 7, 6, 1, and 2. My x is equal to, so 7, 6, 1, and 2. My x is equal to -11/2. And my y was equal to -3/2. All right, perfect. So again, you find the inverse, you multiply both sides of the equation by the inverse, and then once you multiply that out, your position x is the position that goes with x, and y goes at the bottom, so that's y on the bottom. All right, so that's how you do solving 2x2 systems. We're going to take a look at the last question, which is matrix transformations. All right, with this one, it's quite simple in terms of once you understand the concept behind it. So once, assuming that you've understood the concept behind it, I'm not going to do anything that they're doing. I'm just going to go I'm going to do each question showing you the concept behind it, because this way kind of confuses me. But if you want to learn it that way, then please, by all means, go ahead. So the concept is quite simple, actually. If you start off with an original, so I just need a blank sheet. All right, you start off with an original coordinate, okay, with 1, 1. And these are your original points. This point right here, this is going to be my first point. So what's that in terms of x and y? It's 1, 0. And this one, in terms of x and y, is 0, 1. Okay, so this is my first point right here. This is, I guess I'll put 1 and circle it. And this is my second point. Okay, so you start with these 2 points. Now, to write the points out, Okay, you write them simply just like you see like X and then Y, you write them out like that. So my first point is 1, 0. So this matrix is 1, 0. And this one is 0, 1, X, and then Y. All right, this is called an identity matrix. And an identity matrix has ones going diagonally, right? Ones going diagonally and zeros everywhere else. So it's an identity matrix. Once you figure out what you're doing to your identity matrix, you can answer any question that they throw at you. So for example, I want to take my identity matrix and I want to reflect it over the line y equals x. So what we're going to do is we're actually going to go ahead and reflect that. So if I had my line y equals x, just like normal, this one right here, right? If I reflected this point along this line, it would come out to this point right here, right? So this would go over there, and this would go over there. So what does it look like it's doing? So all you have to do is just write down the points and see what it is. So the 1, 0, this point 1, 0 will become 0, 1. And this one reflected over will become 1, 0. Okay. So what has happened? What have you changed? That's all that you're looking at. So this is the matrix for reflecting it over the line y equals x. Okay, this is the identity matrix. So once you're given that, you're just putting that in the answer. So my identity matrix to reflect it. Now this matrix is going to change every time depending on the question. So I'm going to do a few actually. So 0, 1, 1, 0. And then to find this final answer, you just multiply it. So 0 times x is 0. 1 times y is y. So we're just going to put a y up there. Then 1 times x is 1. 0 times plus 0 times 0 is 0. So this is going to be 1x. All right, and then you submit your answer. So I'm actually going to do a few of these because if you understand this concept of how to get the identity matrix for whatever transformation you're doing, you're going to actually understand it. So let me do a few. All right, 90 degrees counterclockwise. All right, 90 degrees counterclockwise. So again, I come here. Okay, I'm going to just erase this question. This is the basis of what I'm going to start with every single time. And this time I am doing 90 degrees counterclockwise. Counterclockwise is, this is how a clock goes. So counterclockwise is that way. All right, so I'm going 90 degrees to the left. So I go with my first point, I go 90 degrees to the left. If I rotated this, if I rotated 90 degrees, it'll at this point ends up there. So my first point is now going to be at 0, 1. And if I take my second point and rotate it 90 degrees, it's going to be down here, which is going to be what? Negative 1, 0. So this second point is negative 1, 0. So this is my identity matrix for rotating 90 degrees counterclockwise. Okay, so once you have that, you come back to your answer and you put those numbers in. So it's 0, negative 1, 1, and 0. Then go ahead and multiply it out, because what this is really this. If they give you a matrix, you multiplying this by that matrix is going to be rotating that matrix by 90 degrees counterclockwise. So this xy is just leaving it in general form. So I'll have 0 times x, which is 0x, plus negative 1 times y, which is negative y. Then here, when I multiply this 2, I'm going to have 1 times x, which is x, plus 0 times y, which is 0. So that's just going to give me the x. And then you're going to submit your answer. So it doesn't matter what the question is, you're just going to do whatever it tells you to do. Okay, I'll just do one more just to make sure. So this one is reflecting over the x-axis. So again, you start off with your original. I'm just going to erase the question that I just did. You start off with the original identity matrix, and then you actually just reflect it over. It says reflect over the x-axis, I believe. So we're going to reflect it over the x-axis. This is the x-axis, and we're going to reflect it over. My first point doesn't move because it's actually on the x-axis, so that's 1, 0. This point, reflecting it over the x-axis, goes 1 down, and then to the line, you reflect it, then 1 over there. So it ends up right here. So this is going to be 0, negative 1. So this is, my second point is 0, negative 1. All right, so this is the identity matrix for reflection. Reflection is a little r over the x-axis. Okay, so again, you come back to your answer. they're asking you what is that identity matrix to reflect. It's going to be 1, 0, 0, negative 1. And then go ahead and multiply them out. 1 times x, which could be 1x, plus 0 times y, which is 0. So this is just 1x. And this one is 0 times x, which is 0, plus negative 1 times y, which is negative y. Okay, so once you find the identity matrix, you just go ahead and multiply it out. And if they gave you a matrix, you would find your identity matrix, multiply that matrix, will give you a new matrix. And that's pretty much it. So no matter what the question is, just go ahead and find the identity matrix and then multiply it out. So over the y-axis, you would take the original point and reflect it over the y-axis and go from there.